All right. So we've covered not everything in biology, but not by a long shot, but enough that you've got some kind of sense of what the field is all about. There are certainly areas that we haven't covered or only briefly touched on, but hopefully this is a passable foundation for whatever further studies you want to go on to. And biology really does touch every aspect of life. I probably don't really need to tell you this because, you live in a world where you're bombarded with messages about everything from global climate change to the COVID pandemic. I saw the news reports on the Omicron variant, and I immediately thought of you folks because I was thinking, hey, wow, we talked about protein shape and we've talked about viruses, so they know about the spike proteins, and we've talked about mutations. A lot of that's straight out of this course. And I want to end this, and I want to end the section on ecology with a little bit more application. All right, I'm a professor in this stuff, and I really like biology. And I've found that a lot of people don't, because when I moved to town, I'd introduce myself to, the people bagging my groceries or changing my oil, and they'd say, so what do you do? And I'd say, I'm a biologist. And they'd look at me like I had just swallowed a live weasel or something. Not everybody is a particular fan of science, and I'm sure, and this is okay, I'm not complaining, but I'm sure this includes some of you. Some of you folks have probably not really enjoyed having to take this course and are just hoping to get your grade and get out and go do something that you're more interested in, which is perfectly fine. There's nothing wrong with that. It means I tend to have a slightly different set of values. And it especially means that I tend to have a slightly different one when it comes to looking at issues in conservation of the living world, the natural environments, the animals and plants and fungi and valcamphiid amoebas and all of the things that we have on Earth. And you've probably heard about the crisis that we've got in habitat loss and species extinction. And I'm one of those hippies who thinks that saving the whales and the pandas and the redwoods and things like that is worthwhile because they're awesome and they're beautiful and they're amazing. But not everybody shares that. And that's why I've kind of pitched this lecture for the business majors here, people who are preparing for a career in a field that tends to inculcate something a little different. So those of you in the College of Business who are going to get your BBAs and go on to be CEOs of the next great thing. You're going to be, high-ranking executives after the next corporate merger. You're going to be in charge of FaceAma Google or something, whatever it is, whatever the next big major is. Face Teslama's Google. This is for you. You hear all this talk about saving endangered species, and some might wonder, well, why should we, what have they ever done for us? So just for fun, this is a panda. This is a Leuropoda melanoleuca. There's a nice Linnaean binomial name. Hopefully you remember what those are. It is an endangered species. They're restricted to a very small area of China. And they are absolutely adorable and cute and fluffy. And half of you are probably going, "Aw," right now. So we know that the panda is endangered, meaning there's not much habitat where it can live, and its numbers in the wild are quite low, and it's possible it could die out. It could go extinct, and we would not have pandas anymore. So here's another species that may not even be endangered. I'm not really sure, but pretend for the moment that it is. This is Dolabella auricularia. It is a hideous sea slug that looks kind of like a mucus-covered turd that can crawl on the bottom of the ocean. And it is covered in slime, and it doesn't have big eyes, and it doesn't have an identifiable face. And it's really disgusting, and it's yucky, and it doesn't even taste good in your gumbo. So if I were to give you folks, let's say I said, okay, I'm an eccentric billionaire, and I can spend a ridiculous amount of money to save either the pandas and ensure that they will survive on Earth for the foreseeable future, or I can save this nasty looking sea slug and let the pandas all die. I'm guessing most of you would probably go with the pandas and would not particularly grieve if Dolabella auricularia were to vanish from the Earth, never to be seen again, right? You know, the panda is the panda the mascot of one of our sororities? Is it Alpha Sig Tau or something? I can't remember which, but one of our sororities has pandas as its mascot. I'm willing to bet there is no sorority that will ever have a sea slug as a mascot. So which one is worth more to humans? Which one do we value more? If you think this is a trick question, you're probably right. Dolabella is poisonous if you eat it, and you find this with a lot of soft-bodied sea creatures. Dolabella's got no shells. It's completely squishy. And there's a lot of things in the ocean with teeth. So instead of using a shell for defense, Dolabella auricularia is poisonous. Here's the thing. An awful lot of poisons are also very useful as medicines. In fact, there was a guy back in the 1500s named Paracelsus who used to say that the dose makes the poison. You know, take a medicine in the wrong dose and you can poison yourself. Take a poison in the right dose and sometimes you can cure yourself. And beginning in the 1980s, when some scientists started looking at the actual toxins in the body of Dolabella, they found some compounds that they called dolastatins that blocked mitosis. You do remember mitosis. It's cell division, right? Interphase, and then prophase, metaphase, anaphase, telophase. The chromosomes move because they're attached to spindle fibers. Go back and look this up if you forgot. Dolastatins mess with the spindle fibers and they'll block cell division.
So does this cure cancer?
Well, there's no single cure for cancer because cancer's not a single disease. It's, you know, maybe hundreds of different diseases that are all kind of lumped together. But there is a modified version of dolastatin sold under the trade name Adcetris. The official name is brentuximab vedotin. Is actually being used right now to treat certain types of lymphoma, a type of cancer that attacks your lymphatic system. The best known type is called Hodgkin's lymphoma. My wife's mother has a different type of lymphoma. I'm not sure if this treatment is used for her, but it is being used on other patients. And there's other dolastatins in this species and in other species that are being investigated. And think about this, there's about 4,000 other species of sea slug, some of them quite a bit prettier than Dolabella, but they're all soft and squishy, living in a world of predators with teeth. So a lot of them do have some kind of toxins or other chemical defenses. What else might we find if we went and looked? Think it over. What would we get if we could, you know, take what we found in Dolabella and multiply it by 4,000? Maybe we'd find other anti-cancer drugs or safer ones, or ones that are like Adcetris, but effective against other types of cancer. No, I certainly don't wish it on anybody, but some of you might end up having your lives saved by a product from a hideous and disgusting sea slug. Just a reminder, that's what the thing looks like. That could conceivably, ultimately, end up saving your life. And we've got a ridiculously large number of examples of this. You hear about, people in old times or maybe out in the country or something using herbal medicines, but something like 25% of all prescription drugs were originally discovered in animals and plants. Oftentimes we can make them artificially and we don't need to extract them from living animals and plants, but animals and plants were where they were first found. Here is, I will probably not pronounce her name correctly, but I would say Tu Yoyo. She's a Chinese researcher who won the Nobel Prize for Medicine in 2015. And she developed a drug called artemisinin from a Chinese plant called sweet wormwood, Artemisia annua. This is currently the drug of choice for malaria, which is not something you folks probably worry much about, but globally it's one of the killers. Last I looked, it killed over 400,000 people each year. Incidentally, the other 2015 winners developed a family of anti-parasite drugs from a soil bacterium. That's the bacterium at the right. It looks a little like a fungus because it grows in these branching filaments that look like hyphae. Technically, it is not a fungus. It is a bacterium. It's a prokaryote. It just grows in an odd way that we didn't have time to talk about. It's called Streptomyces avermitilis. And they developed this family of drugs that are effective against parasites called avermectins. The most famous avermectin is ivermectin. Ivermectin, unfortunately, is not effective against viruses. They tested it in the lab and they found out that doses of ivermectin will kill COVID, but those doses are also about 10 times the maximum dose that humans can tolerate. So if you took enough ivermectin to kill COVID, you'd take enough ivermectin to poison yourself pretty badly. So yeah, it's not really effective against viruses, but that's okay because it really is effective against parasites. That's why it's used in agriculture. It will treat, roundworms and liver flukes and things like that in your livestock. Veterinarians might use it for parasites like heartworm that could affect your dog or your cat. And it's used to treat human diseases. There's a roundworm in Africa that causes a disease called river blindness. In that continent, it's a major cause of blindness. And ivermectin is being used successfully to fight that. And it all comes from a little bacterium that grows in a funny way and is probably present in huge numbers in the soil right under your feet. A lot of the scientists of the past that I've shown you have been dead white guys, and partly that's because up until fairly recently, it was difficult for people like African Americans to get an education in science anyway. But I finally do get to mention one, the African American scientist Percy Julian, who was a chemist who worked out ways to extract compounds called sterols from plants such as soybeans and also from the plant on the left, this rather weird thing with a great big scaly root called Dioscorea barbata, otherwise known as the Mexican yam. He was able to extract sterols from plants like this, and he worked out ways to convert them into steroid hormones. So his work made birth control possible. Not everybody's a fan of that, but it also made possible things like the steroid injections that you might get to take down inflammation. If you've ever had to have a shot of cortisone, in a sore joint or something like that. The ability to make these compounds in quantity, make them cheaply. Percy Julian worked that out, and he did it working with plants like soybeans and this weird dinosaur root thing called Mexican yam. And I could keep going with this. Like I said, something like 25% of all prescription drugs ultimately have an origin in plants, and non-prescription ones too. Aspirin is based on a compound that was isolated from the bark of willow trees back in the 1900s. Over on the other side, there are other chemo agents. There's a compound called etoposide that was first discovered in a plant you can see in the forests around here in the spring, a plant called mayapple, and that's another chemo agent that's used to treat cancer. I could go on with that all day, but not everybody's interested in drugs. So if you're not, here's a South American shrub called Stevia rebaudiana. You can grow this in your garden. I used to. And if you take an extract of the leaves, it turns out that they're 300 times sweeter than sugar, and they don't have any calories. And you can buy the extract in stores right now. It's sold under brand names like Truvia or Purevia. And it's certainly beneficial, and people are making money off it. And it's this product from a pretty but otherwise undistinguished South American little shrub whose common name is sweetleaf. Those are the leaves of a South American rainforest plant called Ilex guayusa. It is related to holly, and Ilex guayusa leaves happen to contain caffeine. You can make perfectly good tea out of them. And there's a company, and I occasionally see their products around here. I don't think they've gone national, but I did see them for a while at my local Kroger. They make these energy drinks from guayusa leaves plus a little bit of fruit flavorings. And they pay Ecuadorian small farmers to harvest guayusa leaves sustainably. Sustainably just means that you can keep doing it. So they'll pick guayusa leaves, but not take them all and not destroy the whole plant and leave the plant to grow more. And they provide income for something like 20,000 Ecuadorian small farmers and also 300 people in the United States. They've been a thriving small business for the past 13 years. And they're doing pretty well, last I heard, and producing a useful product because they're able to work with biodiversity, taking something from the natural world and making it into a product that they can harvest sustainably and sell. And they're doing okay at it. Here's another one for you. That's a weed that grows in rotten soil called Camelina sativa. The common name is false flax. False flax seeds are rich in oil, and the Air Force has been testing a 50-50 blend of their standard aviation fuel with camelina oil, and it works really well. It works. You can fly aircraft without having to modify the engine on this blend. And that's something the Air Force is concerned about because, a sizable amount of our gasoline ultimately comes from countries that don't necessarily like us that much, and in the event of conflict, might restrict supplies. So anything we can do to become more efficient and produce more energy ourselves is potentially a good thing for defense. In September 2011, the Navy's acrobatics squad, the Blue Angels, flew quite successfully using a blend of JP8 and camelina. Or here's one more. This is a rather weird looking creature that kind of freaks people out. It's called Limulus polyphemus. The common name is the horseshoe crab. This is one that's been turned over. You can see these at certain times of year on the Atlantic coast and the Gulf coasts. I've seen them live in New Jersey and also in Alabama. But yeah, you could spot them in Florida or anywhere along the coast all the way to, I think, maybe New York. And the thing about horseshoe crabs is that the blood is very sensitive to bacterial endotoxins, which you might remember are these toxic molecules that bacteria make. Go back and look it up. Even the tiniest traces of bacteria will make horseshoe crab blood clot. So here's some horseshoe crab blood that's being harvested from live horseshoe crabs. And yes, it's blue, it's not red. They use a different pigment, a different molecule to carry oxygen. We've got hemoglobin, which looks red. They have hemocyanin, which looks sky blue. It's being extracted from these crabs, and the crabs can be returned to the water at the end. They're not killed. And the FDA uses horseshoe crab blood to test for bacterial contamination of anything that can be injected. Any medicine that can be injected, any saline solution, and certainly any vaccine. Every batch has to be tested for the presence of bacteria, and the most sensitive test that there is testing it with horseshoe crab blood. So if you've ever had a vaccination, hint, hint, kind of hope you have, or an IV or anything injected into you, its safety was ensured by horseshoe crab blood. And we don't have a good substitute for it. So the bottom line is we've got hundreds of thousands of chemicals that we know of from animals and plants. And we find hundreds more each year. A quarter of all prescriptions written in the US are for drugs that either are produced by plants or were at least originally developed from them. And we're constantly finding more. And as I've said, even drugs that we now can make in laboratories were first discovered in the bodies of plants and animals. I mentioned aspirin is derived from a compound that was found in the bark of willow trees. Sudafed is derived from a compound that was found originally in a dryland plant called ephedra, or the common name is joint fir. Joint fir. I used to see it in the Mojave Desert a lot. There's other products that are useful as sources of fuel, sources of food, sources of dye, sources of all kinds of things. These are things that we get directly from the biosphere, the living world. These are things that people are making money off of. And there's more indirect services that organisms provide. There you've got some bats flying out. And I know many of you probably don't have really warm, fuzzy feelings about bats, but a single Mexican free-tailed bat, a single Tadarida brasilensis, which we do have in this country, flying around at night, that's when they come out to feed, and they feed on insects. And a single one of these bats can catch about one mosquito every 10 seconds all night long. Bear in mind that the largest bat colony in the United States is in a cave outside of San Antonio, Texas. It consists of 10 million bats. So you do the math, one insect every 10 seconds all night long times 10 million. That's a lot of bugs. And insect-eating bats, it is estimated, save US agriculture at least $3 billion a year, possibly more than 15 times that. I've seen different estimates out there. That's $3 billion of crops that aren't lost and pesticides that don't have to be sprayed because of the bats. Here's a couple of beehives that are getting trucked into an apple orchard. There are beekeepers that have literally semi-trucks full of beehives, and they'll drive them from the citrus fields in Florida up to the berry crops, up to the peaches in Georgia and the blueberries in the Carolinas, all the way up to the cranberries in Maine, because honeybees not only make honey, they pollinate. They pollinate your crops. They transfer pollen from one plant to another plant and make it possible for those plants to reproduce and produce fruit. No honeybees means no citrus, no apples, no melons, no cucumbers, no berries, no cotton, no soybeans, and no alfalfa and clover, which you don't eat, but livestock animals do. No beef. And pollination by honeybees, also by wild bees and other wild pollinators, adds at least $15 billion to the value of US agriculture. And about 30% of your food supply depends on pollination. So there is news about honeybee populations dropping. That is something to be concerned about. Honeybees do so much more for humanity than just providing honey and beeswax. They do a lot more. Even when we're not harvesting products and services from living things, we can harvest ideas from them. That's the foot of a gecko. Probably best known for telling you how you can save money on your insurance, right? I'm sorry about the crap accent, but the mascot of Geico is a gecko, that little lizard that speaks in that English accent and keeps explaining how you can save money on your car insurance. Well, geckos are real. They didn't just make them up for the advertising campaign. And real geckos are noted for their ability to climb up almost any surface. They can climb vertical walls. They can climb glass. They can hang from the ceiling with no difficulty at all. And they're able to do it with these magic feet that are covered in many millions of tiny bristles. Yes, I'm sure an Australian or an Englishman would be offended by my accent. We've got at least one English person in class who probably thinks my accent is total crap. Oh well, you're welcome to ask for a refund. Anyway, on the left, that's a picture taken through an electron microscope of the bristles on gecko feet under thousands of times magnification. And a group of scientists, one of whom was one of my teaching assistants back when I was in grad school, have not only figured out how geckos hang from sheer vertical smooth surfaces, they've come up with adhesives that mimic the way that gecko feet work. So you can get this material called gec skin, and a piece the size of an index card can stick to a smooth glass surface. It can support 700 pounds. You could hang off a glass window if you just had like a glove with one patch of this gec skin on there. And yet you can peel it off, leaving with no residue. So imagine if you had this, you could like hang a big TV screen in your dorm room or your apartment. And then you could just peel the gec skin right off and leave no trace, and you wouldn't have any adhesive, and you wouldn't have any nail holes that you have to fill with toothpaste and hope the landlord doesn't notice. This is potentially a very valuable discovery, and it was made by looking at something that geckos have evolved to be very good at over millions of years. There have been a number of inventions like that. Probably the best known would be sonar. the ability to use sound waves to detect obstacles and navigate and detect enemy submarines and things like that, which was based on the echolocation abilities of bats and whales. Yes, Rachel, you could be Spider-Man. If you could make a suit out of gek skin, you probably could climb straight up buildings. The web shooters would probably take a little more work, but yeah, this is for all I know, this is how Spider-Man does it. Right. So designs like that are called biomimetics. We can get ideas for products and make things and sell them and get wealthy, if we're lucky, by studying the natural world. So there's direct economic benefit, completely apart from the fact that critters like pandas and bald eagles are cute or majestic or adorable or otherwise aesthetically pleasing. So I hope you see there are, again, something like 1.8 million species of eukaryote on Earth, plus probably another 6 or 7 million that we haven't even discovered yet. And it can be good business to preserve them. You can't really preserve single isolated species, though, because there's no species of any living thing that's truly isolated. You're looking at one case where we did save a single species. That is an American condor chick. American condors are the largest flying birds, certainly in North America. I'm not sure about the world. They might be duking it out with some of those Australian eagles, but they're huge. And when their numbers dropped to about 20, the last of them were caught and reared in captivity for a while before they could be reintroduced to their habitat. And that's a condor chick that's getting fed by a hand puppet. That's not a live condor feeding the chick. That's a hand puppet. They had to be reared that way so they wouldn't learn that humans were mom and dad. And that's a case of one species that was successfully preserved. But you really can't do that as a full strategy, because every living thing depends on its food sources, its symbionts, possibly even its predators. You know, every living thing is connected to other living things in its ecosystem in lots of different ways. You could say there's no such thing as a single organism. And there's an adult California condor. And if you want to save them permanently, you have to protect the ecosystems that they live in. You can't just say, okay, we'll save species A, B, and C. Species D and E don't provide anything useful, so we'll just let them die. But D and E might provide something necessary for species A, B, or C that you do want to save. You can't pick out only the species that you like. You've got to save the whole thing. You've got to protect the entire ecosystem that species are a part of. So it's not enough just to raise baby condor chicks. You've got to protect Southern California desert, which is where they live. So I'll ask you a slightly different question. Here is a magnificent scene in the Ozark Mountains. The fall colors are in, so the trees are turning hues of gold and red. It's majestic and it's inspiring, looking across the valley to the distant mountains. And no doubt there are adorable furry animals gallivanting and cavorting in this delightful Ozark Mountain scene. So would you rather preserve this ecosystem or this disgusting, slimy, mosquito-infested, stinky coastal salt marsh of Louisiana? So which one do you like better? The majestic mountain habitat of the Ozarks in beautiful fall colors, or a whole bunch of stinky mud that's full of mosquitoes? Actually, I'm from Louisiana, and where I'm from, we call that, the backyard, pretty much. And yes, it's true that both are beautiful in their own way, and there's really no answer to this. This is more just to stimulate thought, but there's no right answer. You can like whichever one you want to. But something worth remembering about salt marshes is that, Meshed, down in South Louisiana, where I'm from, the wetlands of Louisiana, they do produce an awful lot of mosquitoes, and they sometimes smell funny. They also provide about 16% of the US seafood catch. Oysters are a big one. Shrimp are a big one. They produce furs. They produce opportunities to hunt duck. That's a big deal where I'm from. They provide places where my dad can drive down from Lafayette down to the coast and spend the day fishing for redfish or black drum. They provide recreation. They purify water because you can take contaminated water, even raw sewage, put it into a wetland, and the bacteria and the plants will very quickly take all that stuff up and break it down. You can put wastewater into a wetland and get clean water out the other end. There are actually communities that have done that as an option for sewage treatment. The other big thing is that they're a barrier against hurricane damage. Those wetlands are between the open ocean and the dry land, or mostly dry land. And wetlands like that block waves and storm surges. It's been estimated that the value of all US wetlands for storm protection, somebody estimated that at $23.2 billion a year. That's $23.2 billion that didn't have to be spent on rebuilding homes, that didn't have to be spent on, insurance company payouts, that didn't have to be spent on higher insurance premiums because there's a greater risk of storm damage. And the loss of those wetlands, Louisiana's losing, last I looked at, the rate worked out to something like one football field's worth of wetlands per hour. And that was a major contributing factor to the devastation of Hurricane Katrina. New Orleans used to have 50 miles of wetlands between it and the open ocean. It mostly doesn't now. And if that stuff had been in place, I'm not saying the hurricane still wouldn't have been bad, but some of the bad effects of Katrina, the hurricane that my sister barely escaped, some of those effects would have been mitigated if we'd still had those wetlands present. So that's why it's a bit of concern that the US has lost half its wetlands since 1900, and Louisiana's lost 2,000 square miles in 8 years. On the left is a current state highway sign. On the right is what a state highway sign would look like if we took into account the loss of Louisiana wetlands. The state's not as big as, the state's not as big as it looks on the standard map. Okay, maybe you don't like stinky, mucky wetlands full of mosquitoes. Here's a coral reef for you. Coral reefs are critically endangered ecosystems, partly because of human activity and partly because of climate change. Somebody worked out in 2003 that if you could preserve all of the world's coral reefs as they are, or as they were in 2003, you could generate something like almost $30 billion of economic activity, $5.7 billion in seafood, that could be harvested sustainably, i.e., you can keep doing it to not destroy the reef or the seafood population. 9 billion in protecting coast from storm damage, because in tropical areas, coral reefs also can armor the land against damage from storms. Almost 10 billion from tourism and recreation, because a lot of people like to go to places and dive on coral reefs and spend money on everything from, oxygen tanks and dive equipment to relaxation with Mai Tais at the local bar after they're done scuba diving. People spend money on that. And by the way, they'd also get 5.5 billion per year would be the value of future drugs, because there's a lot of sea critters that are toxic, and they have toxins that are being investigated as, future pharmaceuticals. So if we could preserve all the reefs as they were in 2003, we could generate $30 billion of economic activity each year, and it would be sustainable. We could keep doing it. We wouldn't run out. And then probably the single most important ecosystem for human welfare is the soil under your feet. Bacteria, fungi, plants, protists, earthworms, slugs, snails, insects, the little soil amoebas that I did my undergraduate research project on back a long, long time ago in a galaxy far, far away. Well, it was 1991 anyway. That's what makes soil. We can't truly make artificial soil. It's made by the activity of one of the most complicated ecosystems there is, and one that we really do not fully understand. The ecosystem of living things in soil is so rich, it's been called the poor man's rainforest. We still don't understand it very well. There's a lot of mysteries about soil biology, and yet virtually all of our food is grown in soil. And so we're dependent on this whole ecosystem that nobody knows much about. Well, back in 1997, a guy by the name of Robert Costanza tried to put a price tag on the whole thing. And there are some criticisms about exactly how do you value something like the biosphere. But in 1997, the total value of the world's economy, the GDP, was $18 trillion. That's the value of all of the goods and services, everything that somebody made and got paid for, or did and got paid for. Costanza looked at the value of all of the goods and services that the natural environment provides for free. That's everything from the value of tourism to places like coral reefs or fall foliage or places like that. That's the value of soil, the value of the oxygen that plants and protists produce, the value of new drugs, the value of coastal protection, excuse me, the value of everything that's out there came out to be at minimum 33 trillion. That's nearly double the value of the official GDP, possibly as much as 56 trillion. So we'll call it at least 2 to 3 times the value of the global economy. All that stuff you study in the College of Business, biology is 2 to 3 times bigger. So why is our building not 2 to 3 times bigger? I want to know. Grumble, grumble. Anyway, that's the kind of thing we're dealing with. They did a follow-up in 2002. If you could invest $45 billion to preserve most of the wilderness and ocean that's left, you'd get 100 to 1 return on your investment, because that would yield between $4.4 and $5.2 trillion of benefits everything from cleaner water to cleaner air to new food sources, new drugs, other new products, and so on. With the stock market these days, you're lucky if you get 10% a year. Here you're getting 100 to 1 return is 10,000% per year. That's a lot. The problem is that many of the benefits of conservation are what economists call public goods, meaning that regardless of whether anyone pays for them, people benefit from them. So having clean air is a good thing. It's better to breathe clean air than dirty air. Dirty air will make you sick, maybe make you die younger than you should. But nobody's figured out a way to tax air, although I'm sure that economists are trying. You benefit from having cleaner air, but you don't have to pay for having cleaner air. That's what we mean by a public good, something that benefits everyone, whether you're paying for it or not, as opposed to a private good that benefits only the people who buy it. And so the problem with modern economics is that people are very good at, how do I want to put this, spreading harm around while keeping profits as private goods. So if you clear cut the truffula trees like this guy, how bad can this possibly be? Well, yeah, how bad can this possibly be? Well, the losses of the brown barbaloots and the singing fish and all of that, the loss of water purification, the loss of beauty and all that gets spread around everybody in the neighborhood. The profits go directly to the people who are cutting the trees down. The people who own the giant chemical plants in very poor areas along the Mississippi River where it flows through Louisiana, the negatives of that, like increased pollution, increased cancer risks, and so on, those get spread out to the community. The profit goes to the person that owns the plant. And costs like this are called negative externalities. Those are costs that have to be paid whether or not people choose to pay them. So if you're living downwind from a polluting factory, you pay a cost in terms of poorer health, quite possibly shortened lifespan, greater risk of cancer or something like that. And you pay it whether you wanted to or not. That's a negative externality. A positive externality would be, something like clean air, which benefits you regardless of whether you're paying for it or not. And a problem with contemporary economics is that it's very good at spreading out the negative externalities. And this sets up a situation called the tragedy of the commons. Back in the old days, a village might have what they called the commons. That was pasture land, grassland that the entire village owned, and everybody in the village could raise their own sheep, let's say, raise this on this land that was owned in common by everybody. Let's say we've got enough grass to support 100 sheep in our commons. And let's say we've got 10 families in the village that have 10 sheep each. Okay, one guy gets the idea, hey, I'm going to add 11 sheep. I'm going to have 11 sheep in my flock. That means I'll have 11 sheep making me wool that I can sell. So I get all of the benefit of having 11 sheep. The cost of having 11 sheep is that everybody's sheep is going to be a little bit less well fed because I've got this extra sheep but the cost of that sheep is going to be spread to everybody. The benefits are all going to go to me. So that's perfectly, that's sound economic thinking, except all of that guy's neighbors are going to be thinking the same thing. And they're all going to be thinking, wait a minute, he's got 11. Why don't I add a sheep to my flock so that I have 11? And the benefits of owning that sheep all go to me, and the negatives of having that sheep get spread around among everybody. So everybody keeps adding sheep until eventually the commons is grazed away. There's no more food and everybody loses. And so when you have the cost of using a resource is shared is one of these externalities, but the benefit goes to individuals. What basic capitalist economic theory says you should do is maximize the use of that resource, except for the fact that the end result is that the resource gets destroyed. And that's why we call this the tragedy of the commons. Classic real world example, that's a fish called Atlantic cod, Gadus morhua. Used to be incredibly abundant in the North Atlantic Ocean, off the coast of the northern US, Canada, Iceland, Great Britain. This was the main source of fish and chips for many years. You could dry it and preserve it for a long time. So it was a very cheap and very nutritious source of protein that people fished for hundreds of years. And beginning in the 19th century, as technology improved, fishermen did what economics theory says that they should do. A successful fisherman would invest some of his profits in a bigger boat. And then as the technology got better, fishermen who were successful would invest some of their profits in refrigerated holds where fish could be frozen as soon as they were caught. So they didn't have to come back to home port every day. They could stay out for days or weeks on end. And then as technology improved, okay, sorry, I'll try to speed up. Sorry, somebody yawned real loud. I know. As the technology improved, they started adding sonar fish finders. Ultimately, the really successful ones are these giant floating factories that can freeze hundreds of tons of fish each day. And that's the result. The fish catch since 1850 in Canada increased from 1850 to about 1960, shot up, and then collapsed. So much so that in 1992, the Canadian government had to shut down the cod fishery for the simple reason that there weren't any fish to be caught. Every fisherman had done the right thing under economic theory, invested their profits in growing their business, but because everyone was doing it, the end result was complete destruction of the business. Only now are we starting to see some recovery of Atlantic cod. So how are we losing biodiversity? Well, we're losing habitats. In the past 400 years, there's 27 different biomes that the United States has lost 98% of. I'll show you one in a minute. Last I heard, the Brazilian government was cutting down or allowing to be cut down 20,000 square miles of Amazon rainforest each year. In some areas, one of the threats is introduced species that are brought in. They're not necessarily bad, except that they don't have natural predators or consumers to keep their numbers down, and they can spread and choke out native life. So kudzu, the vine that ate the South, is a classic one in places like Mississippi. It's an Asian vine that was introduced for erosion control. And you drive Mississippi back roads and you'll see whole houses and farms that just got swallowed by kudzu. I ain't wrong. In Arkansas, a big one is Japanese honeysuckle and Chinese privet. Those were introduced as ornamental species, and they're outcompeting native plants. Asian zebra mussels are one that we find in our rivers. Probably the most notorious case of habitat loss is cutting down tropical rainforest for timber and pasture, but it happens here as well. California's lost possibly as much as 95% of a biome called vernal pools. These are shallow freshwater pools that fill up in the winter and may dry up completely in summer, but the life in them is adapted to get through that drought and can come back. And California's lost possibly as much as 95% of their vernal pools, mostly because of the mass building of suburbs. Much of the US used to be covered with old growth forest. Here it's called virgin forest, but it just means forest that had never been logged, forest that had reached the end of ecological succession. Old growth forest is the climax community around here. There's an estimate for how much old growth forest we had in 1620 at the top. Lower down is how much we had in 1926. And because this is a climax community, it takes hundreds of years to regrow an old growth forest. It doesn't just automatically pop back up. We can't leave it alone for 10 years and expect to get it back. We just have little fragments of what's left. Up until about 2010, the US was losing forest every year. It's actually slowly starting to come back, but it's not going to be anything like the way it was. And we've lost not just those big trees, but many species that depended on them. We have threats to biodiversity coming from global climate change, and we're already starting to see things like insect pests and insects that carry disease spreading into areas where they did not used to be able to live because the winters on average are getting milder. About 10 years ago, I read that Great Britain finally had acquired a permanent population of stink bugs. Because now the winters were not consistently cold enough to kill them all off. We're starting to see some species that are timber pests moving north into forests that didn't used to have them. Population growth and consumption. If for all that people talk crap about the United States, people globally aspire to our lifestyle. They'd love to have everything that we've got. But to provide a US type lifestyle for everyone on the planet, we'd need 4 more planet Earths for all of those minerals, all that metal, all that wood, all that food, all of the things that most of you listening to my voice take for granted. And all of this is working out that we are losing species forever. Once you lose a species, it doesn't come back. Evolution might produce new ones, but it's never going to produce that one. And we're losing them at a rate that's been estimated at 150 per day. Many of them species that we aren't even aware of. There are a lot of cases of scientists who are discovering new species in museum collections that might have been made 20 years ago and finding that the species is no longer alive, that the only record that they've got would be these skins or skeletons or alcohol preserved specimens that are sitting on museum shelves. We're losing species before we even knew what they were. We're losing them before we know what value they might have for us. For all I know, the disease that's going to kill you could have been treated by some product produced by a plant somewhere in the world, except that plant went extinct when the last little fragment of its habitat got bulldozed. You know, we could well have just lost forever some incredible benefit, and we'll never even know what it was. So I'm only going to end with the words of the Lorax, that unless someone like you, heck with cares a whole awful lot, gets off your ass and does something, nothing is going to get better. It's not. You're going to be living, and your children, if you have them, will grow up in a world that is poorer, not just economically, but in so many intangible ways than the world that I grew up in or the world my parents grew up in. There still might be some time to save what we've got. And it's something that everybody can help out into, whatever your career is, wherever your path chooses to take you. But think about this. If you find this science class onerous, everything I've talked about is connected. It's all part of one great whole. And it is a great whole that humanity has always depended on in more ways than most people realize. And hopefully, if for no other reason, that's why I hope you've gotten some worth out of this course. And on that slightly somber note, I will bring this to an end, and I will stop the recording.